Hello students, welcome to the subject of Mathematics 3 for all my mechanical engineering students, myself Dr. Ankit Acharya, and today we will discuss about very important method, direct method, direct method of obtaining particular integral. So direct method is very important because the method of undetermined coefficient and method of variation of parameter. For that the qx, the right side of the function is very important, and it's quite tricky method. Now this direct method is quite easy for some of the function, so first there are five cases normally. First case 1 is e raised to ax plus b. Suppose your function right side, your function is in this form, e raised to ax plus b. Suppose your function is sin ax plus b or cos ax plus b. Suppose your function is a polynomial x raised to m or polynomial in x. Suppose your function is e raised to x into vx. And last one is, the first four case is important. Last case is not so much important. So right now you can ignore. So e raised to ax plus b, sin ax plus b, cos ax plus b, x raised to m, e raised to x into vx, where v is any function of x. So now suppose your first case, particular integral, okay, that is 1 upon f of d into qx. And now your qx is what? For first case, that is e raised to ax plus b. So in this case, just we assume e raised to b is a constant, so e raised to b as it is, e raised to ax 1 upon f of d. And for that e raised to b is constant, just we assume that instead of d we can take a, so f of a e raised to ax, for direct method 1 upon f of a e raised to ax. Clear? So instead of d we can take a. So let's take one more first example, d square plus 5d plus 6 into y, that is equal to e raised to x. So f of m is what? M square plus 5m plus 6 is equal to 0. So the factorization is m plus 3, m plus 2. So m is equal to minus 2 minus 3. These are real and distinct root. So complementary function, that is c1 e raised to minus 2x, c2 e raised to minus 3x, that is very clear. Now particular integral, you can see that 1 upon d square plus 5d plus 6 into e raised to x. Now what is your e raised to x? So compare e raised to x with e raised to ax. So what is your a? A is 1. So now instead of d, what you have to write? 1. So d, instead of d you can take 1. So 1 upon 1 square plus 5 into 1 plus 6. So 1 by 12 into e raised to x. This is your particular integral. Clear? Let's take one more example. D square plus 2d plus 1 into y, that is equal to e raised to x. So m square plus 2m plus 1, that is equal to 0. M plus 1 whole square, that is equal to 0. M equal to minus 1 are real and distinct root. Very clear. This type of example we already discussed in previous session. So because of this real and distinct root, we know that for homogeneous system of linear equation, suppose m1 is equal to m2, then how we can write complementary function, that is c1 plus c2x into e raised to m1 into x. So c1 plus c2x into e raised to minus x. So c1 into e raised to minus x plus c2 x e raised to minus x. So e raised to minus x, y1 is e raised to minus x and y2 is x e raised to minus x. Now particular integral, we know that particular integral is what? 1 upon d square plus 2d plus 1 into what is your function right side? E raised to minus x. So e raised to minus x. By the rule we have to take instead of d minus 1, but because of this e raised to minus x is already a part of the solution of complementary function. Solution in complementary function. So here you can see that y1 is what? E raised to x, and y2 is what? X e raised to minus x. E raised to minus x and x e raised to minus x. Now e raised to minus x is already in complementary function. So in that case we have to multiply with x, and we have to differentiate of this function d square plus 2d plus 1. But again x into e raised to x minus x, that is also a part of complementary function. Here you can see that x into e raised to minus x, that is also a part of complementary function because that is y2. So in that case, we have to multiply with x square, okay, and 2 time differentiation. So first time differentiation is 2d plus 2 e raised to minus x, okay, and also you can see that when we put minus 1 directly, then minus 1 whole square, that is 1, 1 plus 1 minus 2, so denominator becomes 0, and the condition is denominator of course must be non-zero, otherwise we cannot put value, okay. So when denominator becomes 0, this thing happen, okay. So 1 upon 2d plus 2, this is just a differentiation. Now multiply with x square, because of again denominator becomes 0. You can see that minus 2 into minus 1 plus 2. So minus 2 plus 2. So 0. So again differentiation, that is 2 e raised to minus x. Okay. So x square by 2 e raised to minus x. X square by 2 e raised to minus x. This is your particular integral. Okay. And c1 plus c2x e raised to minus x plus x square by 2 e raised to minus x. Okay. Let's take one more example. Now this is for case 2. Okay. Now this is my case 2. Case 2 is what? F of d. Okay. Sorry. Qx. Qx is now your sine. Just a minute. Q of x is sine ax plus b or cos ax plus b. Okay. Or cos ax plus b. So in this case, particular integral is 1 upon f of d qx, but here we use this formula. Okay, what formula? That 1 upon f of d square sine ax plus b, that is equal to 1 upon f of minus a square sine ax plus b. So in general, if I can say in a very simple way, instead of d square you have to take minus a square. Okay, d square, instead of d square you have to take minus a square. So this value is always negative, either 0. Okay, because first whatever your a, suppose a is equal to 1, so a square is what? 1, and put minus 1. So minus 1, suppose your d is 1, then instead of d square you have to take minus 1 square, so that is minus 1. Suppose your d is equal to 2, so what is your d square? Instead of d square I have to take minus 2 square, so minus 4. Suppose your d is equal to 3, so instead of d square minus 3 square, so minus 9. Clear? Okay. Now here you can, and instead of d you cannot take any value, only instead of d square you can take minus a square. Clear? So first complementary function is very clear, that m square plus 3m plus 2, m square plus 3m plus 2 is equal to 0. So m plus 1, m plus 2, that is equal to 0. M equal to minus 1, minus 2 are real and distinct root. Okay, so c1 e raised to minus x plus c2 e raised to minus 2x, that is very clear. Now particular integral is 1 upon d square plus 3d plus 2 into sine 2x. Okay, now instead of d square, what is your a? Sine 2x. So compare with sine ax plus b. So a is equal to 2 and b is 0. Clear? So a is equal to 2, b is equal to 0. So instead of d square I can take minus 2 whole square, so minus 4. Okay, so minus 4 plus 3d plus 2. Clear? Instead of d square minus 4 plus 3d plus 2. So minus 4 plus 2. So minus 2, 3d minus 2, sine 2x. Okay. So now because of 1 upon 3d minus 2 sine 2x. So multiply with 3d plus 2 and divided by 3d minus 2. Okay. Because of denominator we have only 3d minus 2. So 3d minus 2, 3d plus 2 and sine 2x. Now in denominator here you can see that a minus b, a plus b, so that is a square minus b square, so clearly 9d square minus 4, and in numerator we have 3d plus 2 into sine 2x. Now again in denominator now you have d square, so instead of d square now you can take minus 4, so just I write here 1 upon 3d plus 2, okay, 9 into minus 4 sine 2x, okay, so minus 40 minus 36 minus 4, so minus 40 minus 1 upon 40, and now this capital D in numerator is nothing but the differentiation, okay, differentiation of the function. So 3 d into sine 2x, So cos 2x, okay, differentiation of sin 2x, that is cos 2x into 2, okay, so 3 into 2 6 plus 2 sin 2x, okay, clear. So 6 cos 2x plus 2 sin 2x divided by 40 and minus 1, okay, so minus 1 by 20. Now here you can see that 2 will be cancelled out, 2 and 2 will be common and cancel out with 40, so minus 20. So the final answer is minus 1 by 20, okay, cos 3 cos 2x plus sin 2x, okay. So this is your particular integral, okay, for case 2, sin 2 sin ax plus b or cos ax plus b. For both the case, the rule is common, okay. Now let's take case 3. Discuss about case 3, polynomial, okay. 2x square, y double dash plus 2y dash plus 3y, that is equal to 2x square. So for that, first of all, we find complementary function, that is d square plus 2d plus 3. So m square plus 2m plus 3 is equal to 0. So m is equal to minus 1 plus or minus root 2i. Okay, so complementary function is e raised to minus x c1 cos root 2x plus c2 sin root 2x, that is clear. Now 1 upon d square plus 2d plus 3 into 2x square. Here we use binomial theorem, okay. The maximum power of okay, just to be common constant. So 3 is constant term, so you can take 3 will be common, so 1 by 3, 1 plus d square plus 2d by 3, okay, 1 plus d square plus 2d by 3, so 1 plus d square plus 2d by 3 inverse, okay, so 2 by 3. Now here we use binomial theorem for case number 3, okay, polynomial, so 1 plus d square plus 2d by 3 inverse. For that we use binomial theorem, that is 1 minus d square plus 2d by 3 plus d square plus 2d by 3 whole square and so on up to and x square. Now simple multiplication, 1 into x square, okay, so x square. Now d into x square, d into x square means what? Differentiation of x square, d is nothing but d by dx, okay, so d by dx of x square, that is 2x, d square into x square, okay, so second differentiation, so that is 2, and d cube, from d cube this becomes 0, okay, because third derivative of x square, that is 0. So up to, instead of d I can take 2x, instead of d square I can take 2, okay. So x square minus 2 by 3, okay, d into x square, so d into x square. Now instead of d into x square I can take 2x, okay, instead of d square I can take 2, so 2 by 3, and here 4 by 9, okay, 4 by 9 d square x square, so 4 by 9 into 2. In the final calculation, you will get this term 2 by 3 into x square minus 4 by 3 into x plus 2 by 9. Okay. So this is for case 3 polynomial. First case is for e raised to ax plus b. Second case is for sin ax plus b or cos ax plus b. Third case is for polynomial. Okay. And for that we use binomial theorem. This is case number 4. D plus 2 whole square into y, that is equal to e raised to minus 2x sin x. Okay. So first we find complementary function, that is n plus 2 whole square, that is equal to 0. Minus 2 are real and repeated roots. So complementary function, just we write complementary function, just we can write c1 plus c2x into e raised to minus 2x. Okay. So e raised to minus 2x and y1, okay, c1 plus c2x into e raised to minus 2x. Now for case 4, try to understand this particular integral is this 1 upon f of v, okay, e raised to ax into vx, v is any function of x. So for that we apply this rule, e raised to ax 1 upon f of d plus a. So instead of d we can take d plus a, we have to take d plus a. So e raised to minus 2x outside, and instead of d I can take d minus 2, okay, d minus 2 plus 2. So now 1 upon d square into sin x and 1 upon d square. Now we know that d into f of x is what? Differentiation of f of x. Now similarly 1 upon d into f of x, that is just integration of f of x, okay, clear. Similarly d square f of x to second derivative, but 1 upon d square then second integration, clear. So here you will get 1 upon d square of sin x. So second integration of sin x, that is first integration is minus cos x, and then second integration, so that is minus sin x. So e raised to minus 2x into minus sin x, so minus e raised to minus 2x into sin x. Okay, and the final answer is complementary function plus particular integral. So in today's session we discuss about very important method, shortcut method to find particular integral for four cases. First case is e raised to ax plus b, second case is sin ax plus b cos ax plus b, third case is polynomial, for that we use binomial theorem. Okay, in first case instead of d, e raised to x plus b, so instead of d just we take a. Okay, in second case sin x plus b or cos x plus b, instead of d square we have to take minus a square. Okay, in third case polynomial we use binomial theorem. Okay, in fourth case we apply this rule that particular integral is 1 upon f of d e raised to ax into vx, where v is any function of x. So e raised to ax outside. Okay, instead of d now you can take d plus a. Clear? And this four case is very important. Try to solve more and more example of this shortcut method. Okay, up to this, thank you.